Good morning, students. In this video, we are going to discuss about the stack ADT in data structure. Okay. Stack ADT, first of all, it is a linear data structure. Okay. These are only some of the real-time examples for our stack operations, like arranging the dressing cupboard, then arranging of the some of the things, books, okay, then plates, something else. Okay. Then also in the some of the queue operations also it is shown in the real-time example for our stack operations. Okay. So the stack operation, it were two kinds of operation. It could be done in the stack ADT, insertion and deletion. But while they are performing this operation, it could be takes place only in the one end. The two operations, the technical terms which is used in the stack ADT are push and pop. The technique or principle which is used in the stack is LIFO. Then there are the two exception conditions may arise while we are performing this insertion and deletion operations are overflow and underflow. If the stack is full, if we are trying to insert the new element, then this overflow condition may occur. If we are trying to delete the element when our stack is empty, then that time the underflow condition will occur. These operations, these two operations are implemented by using array implementation and linked list implementation. So first we will start with the push operation. Push operation, it is another name is called insertion. So it is a process of inserting the new element into the stack. Then every new push operation, the stack will be incremented by 1. This is the example. First you have to consider the empty stack with 5 index value. Then while stack is empty, the top of the pointer will be pointed as -1. Here while we are performing the operation, we will use the 1 pointer top. Okay. Then next, if you want to insert 10, okay, at that time the top pointer will be incremented by 1. And now the top will be pointing the index value 0. Next, if I want to insert 20, again the top value will be incremented. At that time, the top will point the index value 1. Okay. So while we are performing the insertion operations, the stack pointer, that is the top of the stack pointer, it will be incremented by 1 and it will insert the newly arrived variable. The next one is the pop operation. Pop operation is nothing but the deleting an element from the stack. This will be used to pop the operation. While we are performing this, it will be decremented by 1. So initially, our top of the pointer, it will point the index value 5. So here, while we are pushing the values, we will use the top plus plus, here we will use the top minus minus. So it will decrement the value and delete the previous value. Then this is, first we will start with the array implementation. Array implementation, here we will use the stack with array. Initially, the stack of empty will be denoted as -1, and it will use the push operation and pop operation. While we are going with the push operation, it will use the stack top, and for both operations, it will use the top of the pointer. And this is the some of the declarations which is used in the stack operations. Then next, this is the routine to create a stack record. Hash defined global declaration is used. Then stack record. We have to specify the capacity, what will be the top of the stack, and where the element type should be pointed. This denotes that it is an array implementation. And this is the routine to create the stack. Stack maximum elements. Okay. These things we will discuss through the example. And this is the routine to check whether the stack is empty or not. Okay. And this routine is to dispose the stack or free the stack. Stack is not equal to null, null. Then this is the routine to check whether the stack is empty or not. And this is the routine to insert element into the stack. Push Okay. Then while we are performing this, we have to check whether the stack is full or not. For that, the routine is given here. And first, we will start with the example. If I would like to insert element 30 into the following stack, okay, what would be the procedure? First, we have to give push of 30. First, we have to ensure whether the stack is full or not. Actually, our capacity of the stack is 6. So, check the stack capacity equal to yes top of stack. Our stack capacity is 6, but the top of the stack is pointing 1. So condition is fails, not equal. So next what it will do, it will increment the stack. Stack point, the top of the stack will get incremented and it will insert the value. Now it will increment and print the value. So initially it is pointing 1. So 1 plus the given stack. So it will points to 2. It will insert the element. Okay. The next routine is to check the whether our cursor is at the top of the stack or not. Then this is the routine to delete the element. Pop stack first while we are going to deletion is empty. During if you are trying to delete a element when the stack is empty, that time it may occur the underflow. So avoiding that, we are checking the is empty. Then this is the example. This is the linked list implementation of stack ADT. Okay, here also you will do push operation, pop operation, and top up operation. And this is the routine to check whether the stack is empty or not. Then next routine is to create the stack using the linked list implementation and check the match empty push operation. And this is the example for the linked list. Then applications of our stack ADT are evaluating the arithmetic expression, balancing the symbols, function call, power of an. These are all the few example of our applications of our stack ADT. The arithmetic expression. Before we are going that, first you should know what is meant expression. Expression is the combination of operands and operators. Arithmetic operations are formed with the help of these three notations: infix notation, postfix, and prefix notations. And this is the example how we have to convert the infix to postfix expression. The purpose of converting this infix expression into postfix expression to evaluate the given expression is correct or not. Okay. These are only some of the how we step by step we have to do or convert the infix into a postfix expression. Okay, in my bracket. And while we are going with this, first you should know the priority. The operator precedence you must know. The star is having the highest precedence. Okay. Okay. And this is the process of evaluating the arithmetic expression. After first we have to consider the input as the this infix expression, and first we have to convert this infix expression into a postfix expression. Okay. While we are converting, we have to start reading from equation from left to right. Each pass it will read only one character at a time. Okay. If it is a operator, it will be placed on the input stack. If it is a operand, it will be placed on the output stack array. Okay. Likewise, this is done. Then while we are coming here, if you are trying to insert the star, it will star after that plus, it will violate the property. Okay, if it is if you have star, the next we will read the plus symbol. If you are trying to insert that, then it will violate the property. So we have to pop the symbols from the stack. Okay. Then next we have to read the next character is open bracket. Then likewise, this will goes on. Then at final, it will be converted like this. Final output will be like this. And the balancing symbol, it will read the character until it encounters the delimiter hash. Okay, whenever it encounters this augmented variable, then it will stop reading and it will check for the matching. The given example is given. Open bracket, it will push on to the stack. Then next is operand, so just it will omitted. Plus it will be placed onto a stack. Then the next one is B. B is a operand, so it will be omitted. Then next one is closing bracket, it will be placed on the stack. Both are balanced. Then next one is the augmented variable. Now at that time the stack is empty. So the above expression will be a balanced one. And this is the function call. Function call is nothing but the main function. If there is any subroutines during execution, the subroutines will be called to supply the value to complete the successful evaluation. This book is your reference. Thank you.